All right, guys, so I'm actually going to, we're going to find, it says we're going to find the domain, the horizontal asymptote, and the vertical asymptote. Remember, the vertical is going to be, let's see, we're going to look, and we're going to look for any remaining holes. All right, so remember, the horizontal, we're looking at the variables. Oh, come on. We're looking at the variables. The domain, obviously, we know our domains. And the vertical asymptote, right? We are looking for where x cannot be in the denominator. Okay, so for question A, we actually are going to work this question. So for it to have a common denominator, we're going to assume that this is like a 4/1, and we're going to multiply by the x plus 1 top and bottom. So I end up with x minus 4 times x plus 1 over my common denominator of x plus 1. Multiply that out, I get 1 minus 4x minus 4 over x plus 1. And of course, I end up with negative 4x minus 3 over x plus 1. Okay, so there's my final answer. Now from there, I am going to do my, first of all, my vertical asymptote is the one that I can think of right off the top of my head. I know I'm going to take that x plus 1 for the denominator, set it equal to 0, and I know that x cannot be negative 1. So I have a vertical asymptote of x equals negative 1, meaning I'm going to have a dotted line at negative 1 because it cannot be negative 1. My horizontal, if I remember correctly for my horizontal, I actually am just taking, right, my variables in the front, and I'm looking at my negative 4x over x, right? Which technically is just negative 4 over 1, which is just negative 4. So I know I have a horizontal asymptote at y equals, because it's horizontal, it's going to go through the y-axis, it's at y equals negative 4. And of course, we didn't cancel anything out, so we know we have no holes. Okay, B. Remember, I have to factor first, or work the problem first. And I know that that's a difference of squares, so of course that's x minus 1. Just like I said earlier, it's x minus 1, x plus 1. And just like earlier, those x minus 1s cancel each other out, so that I'm left with 1 over x plus 1. So I know I have a hole, right? I have a hole at x equals 1. And whenever I plug it back in, I get 1 over 1 plus 1, which is 1 over 2. So I have a hole at 1/2. Okay. Now my vertical, I have x plus 1, set it equal to 0. So it cannot be x equals negative 1, so I know that I have a vertical asymptote at x equals negative 1, meaning I have a dotted line at x equals negative 1. My horizontal, right, I look at it, I have 1 over, well, if I look at it, I have the original, I have x over x squared, right? Remember, if they're not identical, they don't work, so that I get a horizontal at y equals 0. Okay, C. Remember, I have to factor it down. If I look at the top, I know that I can pull out an x, so I'm left with x minus 4. My denominator is a difference of squares, so I'm actually going to get x minus 4, x plus 4. I get to cancel out the x minus 4s, so that I'm left with x over x plus 4. Well, of course, I know I have a hole at x equals 4. And whenever I go to plug it in, I get 4 over 4 plus 4. So then I get 4 over 8, which of course is just 1/2. So I have a hole at 4, 1/2 on my graph. So I did my hole. Now I'm going to do my vertical asymptote. Remember, I take that x plus 4 in the denominator. set it equal to 0, and I know x cannot be negative 4. So I also have a vertical asymptote at x equals negative 4. And of course, for the horizontal, right, first of all, I just want you guys to know I love, whenever I'm doing all this work, I'm going to make sure that I highlight all my answers because I would hate for them to get lost. There's my whole, there's my vertical, there's my horizontal. Okay. So for my horizontal, right, I look at my original, I have an x squared and an x squared. Well, they are exactly the same. So I'm going to just look at the numbers in the front, which is a 1. So I know I'm going to end up having a horizontal asymptote at y equals 1. All right, D. I have to factor. Well, what times y gives me negative 2, but adds to be 1? Well, I need x minus 2, x plus 1. Nope, I take that wrong. X plus 2, x minus 1. It needs to be a positive 1 in the middle. Okay, now what gives me negative 6 and negative 1? Well, x minus 3, x plus 2, so x plus 2, x minus 3. Well, of course, that x plus 2 is going to cancel each other out so that I am left with x minus 1 over x minus 3. So I know I have a whole, right? I have a whole at x equals negative 2. I have to plug in that negative 2. So negative 2 minus 1 over negative 2 minus 3. So I get negative 3 over negative 5, which of course is just a 3/5. So I have a whole at negative 2 and 3/5. So there's my whole. That's an answer. My vertical, I take that denominator, set it equal to 0. So x minus 3 equals 0. Well, I know that x cannot be a 3. So I have a vertical asymptote at x equals 3. Now, for my horizontal, right, I look at the values in the front. Now, remember, you can look at the original, or you can look at the reduced form. Either one of these works. Remember, x squared over x squared means I get to take and look at the numbers in the front, so that I should just get a horizontal asymptote of y equals 1. Right? Use your cheat sheet. Use your cheat sheet. It will help you immensely. Now we're going to take a look at question number 6. All right, we are going to be doing this in steps. Given our expression, okay, we want to know what are the domain restrictions, meaning I need to first factor so that I can figure out what those domain restrictions are because my domain is determined by my denominator. So domain, denominator, domain, denominator. All right, so I need to factor. What times what gives me negative 4, but adds to be a negative 3? Well, that's x minus 4. Oops, I should probably write my x minus 4. And x plus 1, meaning x cannot be 4 or negative 1. Now it says, give the coordinates of any holes in the graph. Well, in order to figure that out, right, I have to go back up. Did anything cancel out from the top and the bottom? No. So I get to write none because it said so. If there are no holes, write none. All right, C, it says give the equations of any vertical asymptotes. Well, if it cannot be 4 and it cannot be negative 1, well, then I have vertical asymptotes at x equals 4 and x equals negative 1, meaning that's where my dotted lines are going to be on my graph. All right, next, it says give the equation of the horizontal asymptote. Well, let's go look at the original. I'm going to take my values. I have a 5x and an x squared. So I'm going to pull it down here. I'm going to write it down. I have a 5x and an x squared. Well, if I remember my cheat sheet, right? If I have an x over an x squared, nothing cancels anybody out or anything like that. We don't drop them. So it ends up not working, and we get a horizontal asymptote at 0. Now it says E, sketch the graph. And it says include any asymptotes and holes in your sketch and give the coordinate for at least 1 point. Okay, so we're going to do that. First of all, no holes, but I do have my vertical and my horizontal asymptotes, so those I am definitely going to go ahead and draw. I said I had one at 4 and -1, so +4, I'm going to draw my little dotted line, +4. And then I said I had one at -1, so I'm also going to take and draw lines at -1. All right. Let's see. We're going to, if I were to use my little handy dandy cheat sheet, I'm going to see if I can put any x-intercepts and y-intercepts in here. Oh, wait, I also know my vertical, right? Or my horizontal. I know that I have a horizontal at the axis, so it's going to be at y = 0. So I'm going to draw my little line there. So here's my vertical at x = -1 and x = 4. Here's my horizontal at y = 0. Okay, now let's see. Let me see if I can reduce this down. I'm going to pull my cheat sheet down so that it's right where I need it, so that we can use it. Hang on, guys. Okay. All right, so let's start figuring it out. So I don't have any holes, so I don't have to worry about that. But I do have to figure out what is my x-intercept. All right, it says x for the remaining factors in the numerator. So if I didn't cancel anything out, I'm going to use my numerator, which happens to be my 5x - 3. I'm going to set it equal to 0, and I'm going to solve so that I end up move that 3 over. It's a +3 divided by 5, so that's at 3/5. Oh, well, that's pretty vague. So I actually, I do have an x-intercept at 3/5, but that's going to be like right there. So I'm actually going to take my calculator and I'm going to plug it in and see if maybe my calculator can help me. Now, using the original equation, right, we have a 5x - 3 in the numerator. So 5x - 3 in the numerator. The denominator, I can go ahead and put the original into my calculator, okay? We don't want to complicate it. I just want the original to graph. So I'm going to use x squared minus 3x minus 4. Okay, when you are plugging it into your calculator, you are going to have to put everything in the numerator in one parentheses, everything in the denominator in another parentheses. Okay, so we're going to go to our calculator. So go to y equals in your calculator. No, hang on, guys. Looking for my apps. There it is. So we're going to go to y equals in our calculator, and we're going to put in our 5x minus 3. Now remember, in parentheses, 5x, whoops, wrong button. Second quit gets you out of anything you don't want to be in, so go to y equals. All right, we have our 5x minus 3, parentheses, and our division, so divided by, parentheses, x squared minus 3x minus 4, close parentheses, and I'm going to hit graph. Now, because you have played with your graph and you can't see it, I just want to go ahead and double check you. You're going to hit zoom 6 to reset your graph back to center in case it's off-centered. All right, so we see our vertical and our horizontals, right? We see that we have our 3/5 there. So we're actually going to take and we're going to mimic this graph, okay? So I'm going to take and draw. I know that I'm going to use a green color. I know it looks like this guy here. I'm going to zoom in for you. I know that it looked like this guy here. And of course, if I take another little peek at it, that middle one, yep, he goes through. There he goes. Okay, so there's my graph. And it said that it wanted one of those points. Well, we know one of those points. We know the x-axis point, right? So we know that it's at 3/5 and 0. We don't technically need to find any of the other ones because we already have that one. And let's see. All right, we're going to move on to question number 7. Again, it says, answer the following questions about the function. No, I'm not touching anything. There we go. So first things first, what are the domain restrictions? Well, in order to figure that out, we're going to have to factor and start working our problem. So if I'm going to go ahead and factor top and bottom. Top, I have a GCF. I have an x that I can pull out, so I have an x plus 5 remaining. What times what gives me 15, but adds to be 3. Well, we did this problem, so that's going to be x plus 3, x plus 5. Well, I get to cancel out so that I am left with x over x plus 3. Now, it's that reduced denominator that I'm going to use for my domain restrictions. So I know that x cannot be -3, because whenever I go to solve that, that 3 moves to the other side, so it is -3. Now, it says give the coordinates of any holes. Well, I canceled something out, so I do have a hole. I know that the x is -5, right? Because if I were to take that x plus 5 and move it to the other side, it's -5. I'm going to take that -5 and plug it in. So I get -5 over -5 plus 3. Work the problem. I get a -5 over a -2, which is just 5/2. Put them together. So I have a hole in my graph at -5 and 5/2. Right. It says give the equation of any vertical asymptotes. Well, we already figured that out. My domain restriction is my vertical asymptote. So I know that x equals -3 is my vertical asymptote. Now, it says give the equation of the horizontal. Well, I go back to my original problem, right? And I look at those first two problems there. I have x squared over x squared. Right, I'm going to rewrite it over here. So I have x squared over x squared. Well, they are identical, so I'm just going to look at 1 over 1, which gives me a 1. So I know that I have a vertical asymptote at y equals 1. So when I go to put everything into my graph, I'm going to start piecing it together. So I know I have a vertical at -3. So I'm going to draw my line at -3. So -3, I have a vertical. Draw my dotted line. I said I had a horizontal, right, at y equals 1. So I'm going to go to 1, draw my dotted line. Okay. And now, I had a hole, right? I had a hole at -5 and 5/2. So -5 and 5/2. Oh, sorry, guys. All right, if you're doing it on your graph, you might have to figure out what the decimal is. That is actually technically -5 and 2.5 if you need to, so you can graph it. So at -5, 2.5. So I know right there, sorry, we're going to zoom into it because it actually needs to be a hole. So -2 and -2 right here, I have a hole. Perfect, I'm going to make him a different color. I'm going to make him green. All right, I got a big old hole right there. Now, to figure it all out, I'm going to go to my calculator. Okay, and I'm going to plug the original equation into my calculator. I can take a peek at it. Oh, hold on, guys. All right, so go to your calculator. Go to y equals. Come on. Hang on, guys. It's not responding. All right, clear it out. Go to y equals or not. Okay, go to y equals. We're going to put our original equation in. We have x squared goes in one parentheses, so x squared plus 5x, one parentheses. Oh, hold on. It's lagging. I apologize, guys. So, okay, there's your x squared plus 5x in one parentheses, divided by another parentheses of x squared plus 8x plus 15. Again, close that parentheses. And now we're going to hit graph. And we're going to see what it looks like. All right, so it should look pretty similar to what we've got going on. Oops, sorry, guys. So we want to just draw very similar to what they have. So we know that it's going to be in that top left and bottom right quadrants. So we know that it's going to look like this. There'll be a hole there, and then we'll come out to the other side. And then we'll do something similar. We'll come down here, and he'll also go here. All right. Let's see. We got our asymptotes, we got our coordinate planes, and we need 1 point. Okay, well, we can do 1 point. Right? So we're going to go find our y-intercept. Come on. Sorry, guys, last little piece. So we take our little reduced form, which is our x over x plus 3, and we're going to put a 0 in. X plus 3 over x plus 3 over x. We're going to put a 0 in. So 0 over 0 plus 3. Well, we get a 0 over 3. A 0 over a number is okay. So it is 0. So I actually have a point at 0, 0 on my graph. I am done. I plotted all my points. I have made all my asymptotes. I have made sure all my holes are there. I'm done.